This is day 7 of chapter 6, systems of inequalities. So it's similar to systems of equations where everything was equal, but inequality, remember, that's going to be greater than or less than. So there's going to be multiple answers here. So you're going to represent this with a shading. So the first thing you have to do is to be in slope-intercept form. We can see this first one, actually all of them today will be in slope-intercept form. The y-intercept we can see is 1, so our first dot goes at 1. The negative 1 is our slope, so we can go up 1, left 1, because negative slopes fall. Same thing as going down 1, right 1. All right, so then similar to when you were doing these, when you had something like x is greater than 2, remember how you go to the number line, you go to 2, and you would put a dot. You left the dot open if it was not equal to, and then if that equal to line was there, you shaded it in. The way that works for these is when the line is there, you use a solid line. If it's not equal to and you don't have the line, you will use a dashed line. So this is less than or equal to. So the line is included, so I make it solid. I want to be less than this line, so I want to be below this line. I'm just going to go like that for now. Because I want everything that's below this red line, but I also have to find what works for this second line. All right, so the second line, y-intercept is negative 2. Slope is 1/2, so I go up 1, right 2. Same as down 1, left 2. It is a positive slope. Now see how on this one it's just greater than. It does not have the equals to. So this line is not included, so we represent that with a dashed line. Since this one is greater than, I would want to be above that line. All right, so then I have to make both of those inequalities work. I need the space that is below the red line and at the same time above the green line. So it would be the infinitely many points that are in this shaded region. And it's infinitely many because remember these lines would go on forever and forever and forever. All right, so on the second one, y is less than 2. Well, the y-intercept is 2. It has no slope, so it's a horizontal line. It is less than, it's not equal to, so I make a dashed line. It's less than, so I want to be below that line. Less than is going to be underneath. Second line starts at positive 3. Slope is negative 1. So I go up 1, left 1. Same thing as going down 1, right 1. It's less than, so it's not equal to. So I would not use a solid line. I would also use a dashed line. It's less than, so I also want to be below that line. So now I want the space that is below the red and below the green. So I would shade in this space here. All right, oopsie daisies. There are 2 more here. So number 3, I graph the first one. I can see the y-intercept is 1. The slope is negative 2, which would be negative 2 over 1. Since it's negative, I can go up 2, left 1. Same as down 2, right 1. It's less than or equal to. Since it has the equal to, I make a solid line. And since it's less than, I would want to be below. Then I have the second one. Y-intercept is negative 2. Slope is negative 1/2. So I can go up 1, left 2, or down 1, right 2. It would be dashed because it's not equal to, and less than would be below. So I have to be below the green and below the red. So I would be in this space right here. All right, number 4, y-intercept of the first one is negative 1. Slope is 1/2, positive, so up 1, right 2. It is dashed because it is not equal to, and below because it is less than. Second line, y-intercept is positive 1. Slope is 3 over 2, so I go up 3, right 2. Same as down 3, left 2. It does have the line for equal to, so I would make a solid line. And then I want to be above this because it is greater than. So I want the space above my green line at the same time below my red. It's going to be this space here, which looks tiny, but remember, these actually would go on forever. So then any point that is in that blue shaded region would make both of those inequalities work. That is systems of inequalities.